Okay, one more thing before we get to simplifying trig expressions, and that is factoring. If you're fluent at factoring, you could probably skip to the end of this video. There's one idea I want you to consider. If you need some practice with factoring, definitely take the time to practice through this and go through these on your own. It might be a good idea to try these and then watch the video. Hopefully, as you're looking at the first one here, you notice that there are some common factors here, that each of these terms have a y squared in it. That means we can divide out or factor out a y squared from each term. So we go ahead and just divide that out. This first term, if we divide out y squared, we're left with x squared, plus the second term, y to the fourth divided by y squared, we're left with y squared. So we can factor this expression into y squared times the quantity x squared plus y squared. For number 2, we've got x squared minus y squared. Hopefully you'll remember this as a difference of two squares. We have two perfect squares. We can factor this into two terms, one with a plus, one with a minus. We take the square root of the first term, x, square root of the second term, y, squared, and we get y, and factor it into x plus y times x minus y. Not sure if you did it right? Just do a quick check. FOIL it out. X times x gives me x squared. X times negative y gives me negative xy. Y times x, I'm going to rearrange it as x times y, and negative y squared. You'll see our middle two terms cancel, and we're left with what we originally started with. Number 3. Number 3 is similar to number 2. You'll notice we have two perfect squares here. X to the fourth and y to the fourth are both perfect squares. So we can factor this as x squared plus y squared and x squared minus y squared. Now, you may notice after this initial step, this is another difference of squares. So in this next step, we leave this trinomial alone. We can't factor a sum of squares. But now we break this into two parts as well. X minus y times x plus y. And again, if you wanted to check this, you could multiply these two out, get your answer, and then multiply that out. And you would end up with the same thing that we started with. Alright, on to the next one. Number 4, you'll see there are no common factors here. So, my next step is to see how can I factor this so that I can get two terms here that when I multiply them out, I can get back to here. Start by looking at the 2x squared. I need to put a 2x here and an x here so that when I multiply, I get 2x squared. The next thing to focus on is this minus 3. I need to get negative 3 when I multiply this last term by this last term. So to get negative 3, my only options are plus 3 and minus 3. There's a couple of different ways to figure out where to put the numbers. It might be easiest just to try it out and see which one works. If I put a plus 1 here and a minus 3 here and try it out, it won't work. So just switch it around. Put a minus 1 and a plus 3. See if that works. You only have 4 options. And after a little practice, it gets easier. You'll realize that 2x plus 3 and x minus 1 will result in this. Try it out. We already know this gives me 2x squared, and this gives me negative 3. The middle term, though, comes from here. You see 3 times x is 3x. 2x times negative 1 is negative 2x. 3x minus 2x gives me the x term that I need. Alright, the last factoring one here, and then we have a few other things to consider. This one's similar. see we have no common factors. I can't take out a common factor. So I see, can I factor this into two binomials, two terms each? Again, how am I going to get x squared? Well, I need to take x times x. How am I going to get positive 1? Well, pretty much just 1 times 1. It could be negative 1 times negative 1, that would work. But since this is positive, we're going to see this will work out better if we go like this. And now, if you test it, we could test our middle terms. That's going to give me 1x. That's going to give me 1x together. That gives me 2x for my middle term. Now, sometimes you'll see the textbook or others combine these. Since these are identical, we can think of this as x plus 1 to the second power. Alright, two more things to consider. One, simplifying 3 over x squared. Hopefully you just see this and recognize, hey, that's just taking some number times itself, an exponent of 2. In this case, we could put them together. You might want to write 9, but for a moment I'm going to write 3 squared over x squared, because this is really what I'm interested in. If you think back to the Pythagorean identity, I glossed over a point there. I said that tangent of theta was equal to sine theta over cosine theta. But if you'll remember, we actually had sine squared theta over cosine squared theta. Well, using this idea in reverse, I can think of this as sine theta over cosine theta to the second power, which I can then think of as tangent theta to the second power. And at the end, I can write this as tangent squared theta. So I know you trust me, but I didn't lead you astray. This is equal to tangent squared theta. Alright, last thing to consider, and this may be the most interesting thing on this video. I've got two expressions, all numbers. The first expression is a fraction, and I've broken it up into two parts. I've taken the numerator and broken it up, and I've kept the same denominator. My question is, are these two things equal? If you take a minute and look at it, you'll probably recognize it is. Here, if I just add the numerator, I get 3 divided by 2, which is the same as 1.5, or those of you that like decimals, 1.5. If I break it up, this becomes a half, this becomes 1, half plus 1 is 1.5. I do get the same thing, so we know that these are equal. How about over here? Does it work the same way over here? You'll notice the difference. In this case, the denominator is split into two terms. So I split this into two terms. I kept the numerator the same and split the denominator up. Similar to what I did over here, right? Let's try it. Over here, I get 3 divided by 3 plus 1 is 4. As a decimal, you see that's 0.75. Over here, though, look what happens. I get 3 divided by 3 is 1, plus 3 divided by 1 is 3. I get 4. Interesting. This is really the fraction addition rule backwards. Okay? We're used to getting common denominators and then putting them together and combining the denominators into a 2. This is just going backwards, starting with an addition and breaking it up into two separate fractions. That works fine when I'm repeating the denominator and breaking it apart for an addition or subtraction problem. However, that doesn't work when the addition's in the denominator. Take a look. This, bad idea. Over here, this is really useful at times. Now you're ready to simplify trig expressions.